When approaching a project where a homeowner has initiated electrical modifications, a systematic strategy is crucial. Firstly, conduct a thorough assessment of the existing electrical work. This involves a detailed inspection to identify any hazards or code violations resulting from the homeowner's efforts. Determine the full extent of the work already completed and what tasks remain to be addressed. Gather information regarding the homeowner's electrical experience and their level of understanding. Secondly, communicate effectively with the homeowner. Explain the significance of engaging qualified electricians for electrical projects, emphasizing the potential risks and consequences associated with improper installations. Clearly outline the necessity of obtaining a permit and scheduling inspections to ensure compliance and safety. Emphasize your role as a licensed professional dedicated to ensuring the electrical system's integrity. Thirdly, engage with the permit department. Contact the permit department to explain the situation comprehensively. Clearly state that the homeowner began the electrical work but realized its complexity, necessitating professional intervention. Request a permit to complete the project and ensure it meets all current code requirements. This transparency helps establish a cooperative relationship with the authorities. Fourthly, prepare for the inspection. During the inspection process, inform the inspector that the homeowner performed some of the initial electrical work. Explain the circumstances surrounding the situation and detail the steps you have taken to guarantee the installation's safety and code compliance. Provide documented evidence of your qualifications, licensing, and relevant experience as a licensed electrician. Fifthly, address challenges with underground cabling. In situations where underground feeder cable or UF cable has already been buried, the inspector may be unable to verify its burial depth. Discuss with the homeowner the importance of proper burial depth and the potential consequences of an incorrect installation, such as physical damage or electrical faults. If necessary, explore the possibility of requesting a variance from the permit department to accommodate a deviation from the required burial depth. This variance should only be considered if alternative safety measures, such as additional protection or warning markers, are implemented. Sixthly, complete the electrical work according to code. After obtaining the necessary permit, execute the remaining electrical work with professionalism and meticulous adherence to all applicable code requirements. Ensure that all connections are secure, insulation is properly installed, and the circuit is adequately protected with correctly sized circuit breakers or fuses. Finally, arrange for a final inspection. Schedule a final inspection with the permit department to verify that the entire electrical installation meets safety and compliance standards. Address any deficiencies identified during the inspection promptly and thoroughly. Maintaining open communication with the homeowner throughout the entire process is crucial for building trust and ensuring satisfaction. Document all discussions, decisions, and inspection results meticulously for future reference and to mitigate potential liabilities. Consider implementing additional safety measures, such as ground fault circuit interrupters, or GFCIs, and surge protectors, to further enhance the electrical safety of the installation and protect against potential hazards. Remember that as a licensed electrician, upholding the safety and compliance of any electrical work you undertake is your paramount professional responsibility, irrespective of the circumstances. This includes ensuring that the wiring methods and materials used are appropriate for the application and meet all applicable standards. When dealing with existing wiring, carefully inspect the conductors for any signs of damage or deterioration and replace them as needed. Verify the correct sizing of circuit breakers and conductors to prevent overloading and potential fire hazards. Ensure that all electrical boxes are properly grounded and that all equipment is installed according to the manufacturer's instructions. Pay close attention to grounding and bonding requirements to minimize the risk of electric shock. Ensure that all splices and terminations are made within approved electrical boxes and that they are properly secured and insulated. Use appropriate connectors and tools for making electrical connections to ensure a reliable and safe installation. When working with unfamiliar electrical systems, take the time to consult with experienced colleagues or electrical inspectors to clarify any uncertainties or concerns. Stay updated on the latest electrical codes and standards to ensure that your work is always in compliance. Continuously enhance your knowledge and skills through ongoing training and professional development. Maintain a professional demeanor and treat the homeowner with respect and courtesy throughout the entire process. Clearly communicate the scope of work, potential challenges, and any additional costs that may arise. Obtain written approval from the homeowner for any changes or additions to the original scope of work. Properly dispose of any waste materials generated during the electrical work to maintain a clean and safe work environment. Conduct a thorough cleanup of the work area upon completion of the project to leave the homeowner satisfied with the results. By following these steps and maintaining a commitment to safety, compliance, and professionalism, you can effectively handle electrical jobs started by homeowners and ensure the integrity of the electrical system. Additional considerations might include the specific type of underground feeder cable the homeowner used. Was it indeed underground feeder, or UF cable, or was it non-metallic sheath cable, also known as an M cable, which is not rated for direct burial? If an M cable was used, this would be a significant code violation and would need to be corrected by removing the cable and replacing it with UF cable or another approved wiring method for underground applications. The correct burial depth for underground feeder cable depends on the voltage and the location of the cable. According to the National Electrical Code, or NEC, in Table 300.5, for residential branch circuits rated 120 volts or less with ground fault circuit interrupter protection, the minimum burial depth is 12 inches. For circuits rated over 120 volts, the minimum burial depth is 18 inches. If the cable is installed under a driveway or other area subject to vehicular traffic, the minimum burial depth is 24 inches. It's important to consult the local electrical codes and regulations, as they may have additional requirements or restrictions. When explaining the importance of proper burial depth to the homeowner, emphasize that it's not just about meeting code requirements, but also about protecting the cable from physical damage and ensuring the safety of people and pets. If the cable is buried too shallow, it's more likely to be damaged by digging, gardening, or other activities. This can lead to electrical shorts, shocks, or even fires. If it's not possible to verify the burial depth of the existing cable, consider using a cable locator to trace the cable and determine its depth at various points along its length. This can help you assess the situation and determine whether the cable needs to be reburied at the proper depth. When requesting a variance from the permit department, be prepared to provide detailed information about the situation and the alternative safety measures you plan to implement. This may include providing documentation of the existing cable installation, a description of the soil conditions, and a plan for protecting the cable from physical damage. It's also important to be prepared to answer any questions the inspector may have and to justify your request for a variance. Ground fault circuit interrupters, or GFCIs, are an important safety device that can help prevent electrical shocks. GFCIs work by monitoring the current flowing through a circuit and detecting any imbalance between the hot and neutral wires. If an imbalance is detected, the GFCI will quickly trip the circuit, cutting off the flow of electricity. GFCIs are typically required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Surge protectors can help protect electronic equipment from damage caused by voltage spikes. Surge protectors work by diverting excess voltage away from the equipment and into the ground wire. Surge protectors are available in a variety of forms, including power strips, wall outlets, and whole house surge protectors. When installing electrical equipment, always follow the manufacturer's instructions carefully. This will help ensure that the equipment is installed safely and correctly. Use appropriate tools and techniques for making electrical connections. This will help prevent loose connections, which can cause overheating and potential fire hazards. Always turn off the power before working on any electrical circuits. This will help prevent electrical shocks. If you're not comfortable working on electrical circuits, hire a qualified electrician to do the work for you. Electrical work can be dangerous, and it's always best to err on the side of caution. When inspecting the homeowner's work, look for common mistakes such as loose connections, incorrect wiring, and damaged insulation. Pay close attention to the grounding system to ensure that it is properly installed and functioning correctly. Check the circuit breakers to make sure they are the correct size for the circuits they protect. Ensure that all electrical boxes are properly secured and that all wiring is protected from physical damage. If you find any code violations, document them and discuss them with the homeowner. Explain the importance of correcting the violations and provide them with a written estimate for the cost of the repairs. Be prepared to answer any questions the homeowner may have and to address any concerns they may have about the electrical work. Remember, your goal is to ensure the safety and compliance of the electrical system and to provide the homeowner with a safe and reliable electrical installation. This process includes verifying the proper use of wire connectors. Ensuring the proper connections on the wires is critical. For example, make sure wire nuts are not loose or falling off. It's also important to assess the type of branch circuits the homeowner has installed. In a kitchen, there needs to be at least two 20-amp small appliance branch circuits for the receptacles. There also needs to be at least one 20-amp branch circuit for the refrigerator. These are critical requirements that need to be verified. The underground cable needs to be a continuous length from the power source to the shed. There should be no underground splices without using a junction box rated for underground use. This is essential for safety to prevent electrical shock.